Hello everyone and welcome to IMSE in Home Appliances webinar. My name is Tua and I'm here today with my TactoTek colleague Vesa.
Hi guys.
And Kabir from PassiveBolt.
Hello everybody.
And first a couple of practical things. So our presentation duration today will be approximately from 30 to 40 minutes. And at the end, we will have time for your questions. So you can keep sending in your questions at any time during the presentation via the chat box on your right-hand side. And then we will address those at the end of the webinar in the Q&A session. And if you need to exit, just close the browser and you will have access to all the material afterwards, after the presentation. Okay, so let's first have a look at the agenda for today. So like said, the topic of today is IMSE for home appliances. First, we're going to go through some basics, and then we're going to discuss the IMSE for home appliances through some design concepts that we have created here at TactoTek. And also, we're going to have an inspiring customer story from PassiveBolt regarding the Shepherd Smart Lock, which utilizes the IMSE technology. And then, like said, we're going to have the Q&A session. But first, let's go over some basic things about IMSE as a recap. So with increasing existence of electronics and HMIs in our daily lives, there is a clear need for new solutions. Electronics have really become fundamental in all aspects of our lives, in cars, at work, at home, and they are used in infinite applications throughout the world. They are really changing the way we function as humans, as families, and as communities. And electronic functionality is increasingly driving user experiences and at the same time provides toolkits for brand differentiation for OEMs. But there is a problem. Electronics design hasn't been able to keep up with the increasing pace of growing needs and requirements for innovative, easy-to-use, efficient human-machine interfaces. And conventional electronics aren't a good match for many use cases. They have a lot of parts, assembly depth that makes them impractical or even impossible for many use cases, and they carry a high total cost of ownership due to complex structures that are needed even for the simplest of HMIs that every one of us as consumers use every single day in our lives. So how are we able to help out to overcome these challenges with IMSE? Let's have a look. So at TactoTek, our mission is very bold. We are transforming the entire electronics industry by inspiring and enabling intuitive, aesthetic, and smart plastic product designs with injection molded structural electronics. So no longer you have components in a box, but you have beautiful, integrated, smart structures. And as an outcome, IMSE enables delighting user experiences and the ability to really design for differentiation. And at the same time, while we are doing this, we are reducing the complexity for the parts remarkably, which results in efficient total cost of ownership and significantly less greenhouse gases during production. So what you can actually do with IMSE. This is what we illustrate with this simple graph you've probably seen in our other webinars and presentations. The foundation on the bottom, as you can see here, is the IMSE platform. This includes all the verified materials and components ranging from conductive inks to SMT components and all the way to different film and plastic substrate combinations. On top of the platform are the technology modules that we call IMSE building blocks. Those form the functional features that are selected based on the customer need for each respective application and use case. And we have divided the IMSE building blocks into 5 different categories, which are touch, And this refers to, for example, capacitive sensors and sensor groups. And then sense refers to sensoring. For example, you can have a proximity sensor, which would wake up the IMSC-based HMI without actually touching it, but only bringing your hand close to it. And next up, we have illuminate, ranging from small illuminated functional areas to larger, more complex ambient illumination. Then connectivity, printed antennas and coils that follow the contour of the 3D shaped part very close to the surface. And this improves the connectivity performance utilizing surfaces that conventionally have been pretty much dead space. And then finally, we have look and feel. And this is a support for beautiful graphics and materials on different surfaces, creating elegant and distinguished look and feel for every need and taste. And let's not also forget that the benefits that IMSE brings via complementing technologies such as haptic actuators, which can be integrated with IMSE parts as post-process application. All right, that's it for the IMSE recap this time. And now let's delve more deeply into the IMSE for home appliances topic of today. So Vesa, please take the stage.
Thank you, Tua. Thanks for the recap. And again, also from my side, thanks everyone for joining.
Vesa, can you put your camera on so everybody can see you?
Yes, just give me 1 second. Does it work now?
Can you put your slides into presentation mode, please? Perfect.
Yes. Okay. All right, here we go. So let's take a look at a little bit further in detail how we can help revolutionize the designs, specifically in home appliances, with the IMSE technology, and what are really the main benefits we can create. As the headline for today's webinar says, IMSE in appliances. This is what we think we can offer in home appliances. The human-machine interface is one of the most important point of contacts between the user and the product. This applies to any HMI, anything from making your much-needed morning coffee with your coffee machine, or setting the temperature of your home with your smart thermostat. Users navigate through dozens of HMI interfaces and designs every day. And usually and often those designs are compromised by the boundaries of conventional electronics. And we really think that with IMSE, we can help you to do much, much better. At its best, a great HMI provides intuitive and responsive controls to the user, while also enabling beautiful design features that really bring the experience of using the products to a whole new level. With home appliances, achieving cost-effective differentiation between brands can be difficult, and not the least, again, because of the boundaries that traditional and conventional methods of creating HMIs create. On the other hand, an appealing, well-designed HMI as a part of the complete design is one of the keys towards brand differentiation and creating a distinctive brand language, and really to the ability to stand out from the crowd in the eyes of the consumer. So let's start by taking a look at a little bit of the challenges with the conventional components in the box, so to speak, approach, and how we can help to overcome those with IMSE. So conventional electronics and methods of creating HMIs limit the creativity and innovation of what HMIs really can be. Creating a positive brand differentiation from the competition and creating truly innovative smart HMIs that define brand identity is significantly limited in terms of shapes, styles, and functionality, mostly because of the limitations of the conventional methods. And very often, customizing the HMIs in terms of cosmetics, functionality, or both requires new tooling at the very least for some parts of the conventional assembly. And with this conventional approach to HMI, creating seamless surfaces with functionality, great looks, and easy to clean properties is very difficult, if not even impossible. And typically will force the design into a compromise in terms of the aesthetics, functionality, or both. With the conventional methods, also the total cost efficiency is a hard task to manage. Complex part structures that create a need for multiple tool sets, assembly lines, and often complicated and very labor-intensive supply chain setups, anywhere from the individual part suppliers to final assembly factories. Also, customizing the functionality or cosmetics of the HMI not only create challenges in the brand differentiation, like I mentioned before, but also establish challenges in terms of cost efficiency with the tool sets and balancing supply and demand, and of course, in utilization of all those different tools that are created. Thirdly, as with all electromechanical interfaces, the more interfaces the structure has, the greater the risk in terms of reliability. Typically, also, the electromechanical interfaces can be among the highest price line items in the bill of materials. With increasing demand for more sophisticated electronic functionalities, managing both the cost and reliability risk becomes challenging, and creating HMIs that are logical throughout the product categories, which is really one of the main things in terms of brand differentiation and brand identity, becomes increasingly more difficult. So looking at these three major topics, let's break them down a little bit and see how we can help solve these challenges with the IMSE technology, starting with the brand differentiation. Designing beautiful, smart, three-dimensional, innovative HMIs with IMSE technology really enables the use of functional design features as brand identity elements. Now, this could be as simple as illuminated power button with brand-specific geometry, or it could be as streamlined as a full HMI design language that is consistent from every appliance throughout the product lineup. And with the brand-specific HMI, that customers will actually recognize regardless if they are shopping for a coffee maker or a refrigerator. Also, with IMSE, the HMI can be extremely thin compared to conventional HMIs, which really opens up a whole new world in terms of designing possibilities. Not only for the geometry of the part itself, but also in terms of where the HMI can be actually placed within the appliance to create innovative, easy-to-use experience for the user. This also enables the customization of the HMI without actually having to make any changes in the appliance itself, and offers great benefits in terms of customizing the appliance as late as possible in the assembly process. Also, with the seamless single-piece structure that's created with IMSE, keeping surfaces clean, especially HMIs, and in a time like we are living today, keeping these parts clean is very easy, and there's no risk of damaging the HMI or the components inside because of all the functional features of the HMI are encapsulated in plastics. So typically they are, and within the HMI and IMSE structure, they are completely protected from moisture and debris. And of course, they're then safe to be sanitized with most common household cleaners. Secondly, let's look at the total cost efficiency, where we also think IMSE offers very significant benefits. So IMSE part is a single piece structure created with one single injection molding tool. So this cuts down the tooling expenses significantly compared to a conventional HMI structure, where you would need several tools to create all the separate components and parts that then go into the actual HMI interface assembly. Now, this of course applies both to the fabrication of the actual tools, but also to the engineering work of the tools, because every single tool has to be engineered and designed as well, which brings us to the next point. The single piece structure effectively eliminates most, if not all, of the assembly steps in production that are needed to create the conventional HMI. And very often the final assembly phases and steps are done as close as possible to the sales region. Of course, then making some areas of the world significantly less cost competitive in terms of assembly costs. And thus, of course, have a direct impact either to the sales price of the appliance or alternatively to the margin of the appliance. Functional and graphical localization for IMSE parts are done within the printing process, and of course sometimes on the SMT process as well in case of functional variants. However, time-consuming and often expensive tooling changes or secondary tools are not needed. The same applies, of course, for the final assembly process of the appliance, with the ease of printing and SMT changes, and the rest of the processes can be streamlined to optimize both performance and cost effectiveness of the operations. And what this reduced quantity of parts in the process, as well as reduced or even eliminated assembly steps, means is less time and effort spent on design time, less components to manage in the inventory, less vendors to be managed, and significantly streamlined logistics flow to get from making parts and getting parts to the actual functional appliance with the beautiful, innovative HMI. And then as the third major item, looking at the competitive edge. Excuse me. So one electromechanical interface results in durable, reliable, sturdy structure, while keeping the HMI safe from external hazards, such as moisture and debris. With IMSE, advanced intuitive functionalities can be integrated to the seamless single part structure. This could be anything, of course, from high sensitivity capacitive switches with beautiful illumination to incorporating a wireless antenna radiator directly onto the surface or the structure of the part, and pretty much anything from the building blocks that we saw earlier on the presentation. Any and all of those functional items from the building blocks really can be mixed and matched according to the need of the customer. And remember, this can happen without any modification on the tools. With the ability to transform the HMI design into 3 dimensions, intuitive guidance for the user can be created by designing smart geometries directly onto the part. Again, this could be anything from a subtle texture on the surface to a more aggressive guiding geometrical feature that almost magically guides the user to interact with the HMI in a very, very thoughtful and designed way. And lastly, IMSE enables the creation of consistent HMI logic in a single part structure that can be customized to deliver and carry the brand identity throughout product categories. So to summarize these 3 major topics, IMSE adds value for appliances and enables completely new possibilities for HMI design. So what we can say it really is brand differentiation with the total cost efficiency creates competitive edge. All right, next moving on to design concepts. So let's take a look at some of the inspirational design concepts to give you an idea of what really can be done with IMSE. Starting with, of course, telling that the concepts you're about to see are really a virtual design illustration for very product-specific application. And really the main thing we want to highlight is that everything you see here is created and actually can be built using verified IMSE materials, components, and building blocks. So anything you saw from the building block side, all the way from the platform to the different blocks, everything in these examples that you see are good to go in terms of being able to produce. Really, the idea, of course, is not to offer something as plug and play to anyone, but really to highlight the possibilities with IMSE-based HMIs. In our latest case study, we have looked into creating user-intuitive fridge HMI panels for a refrigerator, and what kind of benefits IMSE brings in comparison to conventional technologies. Some of that is going to be talked through today in the webinar, but if you're interested to read the entire case study, please head over to the downloads section of our website at TactoTek.com. So when it comes to a fridge HMI panel design, as an example, what kind of challenges conventional technologies have? Well, conventional electronics create conventional interfaces. Design and integration possibilities are limited by the multi-layer structure, including a separate cosmetic surface, typically a full-size rigid circuit board assembly, and of course other structural components. These panels often require a certain structural installation depth, and also different variants often require costly and time-consuming tool mods. Of course, touchscreens can deliver an aesthetically pleasing experience, but their appeal is really diminished by the high initial cost of the panels. Requirements for complex control electronics, limited form factors, and in the case of specifically in refrigerators, typically a large openings in appliance insulating layers. So creating technically advanced, easy to use HMIs for users without adding to the cost of manufacturing and operations is a challenge that cannot be solved with either conventional HMIs or touchscreens. And providing the consumer with more effective connectivity is one of the methods really of increasing the usability of the household appliances, and at the same time providing OEMs and brands a possibility to really collect data during the lifetime of the appliance, as well as efficiently place the antennas, which typically in conventional electronics assemblies is difficult because of the installation depth and the required space and presence for the materials that actually disrupt the antenna radiator patterns. So with the topics above, design limitations, technology constraints, and cost, they really limit the innovation for home appliances as well. TactoTek, offering the IMSE technology, we think we can really revolutionize the solutions to solve these issues with the IMSE. So solving these issues with IMSE, the HMI really provides direct information exchange between the end user and the product. What it should be is intuitive and simply to use and easy to use. IMSE enables OEMs and brands to use the HMI to create and emphasize their unique brand language with attractive and informative illumination, high performance capacitive touches, proximity sensors and antennas, IMSE can really present a sophisticated electronics functionality with a simple use. IMSE HMIs, again, are seamless, truly three-dimensional designs that guide the user interactions as well as visual appeal. Seamless and easy to clean while using the 3D for aesthetics. A slim panel can be mounted in many different locations, including ones that are not really feasible for HMIs built with conventional electronics. The control panel we see here in the picture actually wraps around the edge of an appliance, making it really easy to assemble and minimizing openings for the surrounding mechanics. Also, with this, IMSE eliminates entry points for dirt and other contaminants by eliminating all openings and gaps created by mechanical buttons and illumination outcoupling points. So cleaning an IMSE panel is as simple as wiping it with clean damp cloth. And again, with the TactoTek verified materials platforms, they're compatible with most household chemicals and cleaners. Consumers today, of course, are living in a home of connected devices, and appliances are increasingly important part of their smart home systems. So antennas, including Wi-Fi, Bluetooth, and NFC coils, perform extremely well within the IMSE solution, in part because the antennas are located within the molded part structure and typically away from a lot of the sources of interference. With IMSE, antennas are printed at the same time as the circuitry and other printed electronic features. So, excuse me. As a design example, we have an IMSE HMI panel for refrigerator. It looks a little less conventional, though it is more on the traditional side in terms of style and design. Having the basic functionalities that a fridge and a freezer HMI needs, but really offering great benefits. So looking at the IMSE feature in this specific design, three-dimensional shape and seamless single-piece structure. We have ambient illumination to signal the status of the appliance. There is a built-in proximity sensor to wake up the HMI functionalities, as well as brand logo capacitive button switch between controlling the fridge and the freezer. In this case, the brand, it's TactoTek. Illuminated symbols that identify which operation you have actually activated between the fridge and the freezer. Capacitive slider for adjusting the temperature. And all the way on the right, alarms for door open and a high temperature or a melting icon. And the power button, that of course is a capacitive touch as well. And if you look, for example, the power button to prevent falsely turning off the whole appliance and melting off all your ice creams and frozen treats, the button actually requires a 3 seconds of activation to switch the appliance on or off. Looking into the IMSE structure of the part itself, so this design is actually the typical, what we call the two-film IMSE structure that the picture here on the left illustrates. So on top of the structure, you have the cosmetic top film that has the icon artworks, all the printed layers to give the part the look and the feel the customer wants. On the bottom, you have the functional film, including all the mounted components on top of the conductive inks, with all the wiring and of course, for example, all the capacitive sensors. And then on the center, you have the plastic substrate that's being injection molded in between these two films in a traditional injection molding process. So as an end result, you create this beautiful three-dimensional single-piece structure with one single electromechanical interface. And again, localization in terms of functional and cosmetic variants are handled within the printing and the SMT process of these parts. So again, the tooling remains the same. Just to give you a basic idea of the functionality of this particular HMI and how it indicates different scenarios, we have a couple of examples to show you. In the first picture, you see the HMI interface in sleep mode. So this is where none of the capacitive buttons are actually functional, and all of the illumination is switched off. On the left, we see how the HMI looks like after it's being activated by the proximity sensor by waving your hand in front of the panel and touching the logo to select the mode, which in this case is the freezer, as indicated by the green snowflake looking indicator you see here. The HMI also indicates that the freezer temperature has been set to -18 degrees Celsius by illuminating the respective number in green below the capacitive slider. And finally, on the last image on the right, the HMI indicates that the door has been left open by illuminating both the door open indicator on the right, as well as the red ambient illumination light on the left side on the curve of the HMI panel. Then looking as a second example, we have a little less traditional take on a very similar logical HMI interface. So this HMI actually has a very similar functionality compared to the previous example. And of course, it is also done for a refrigerator and a freezer, but offers a little bit more aggressive take in the shape and design of the HMI as such. This also has a proximity sensor built in to wake up the HMI, but only the brand logo and some cosmetic elements are visible when the HMI is not used. Everything else in this panel is actually hidden to the lid. And for example, if you look at the logo in the center, this could be easily just a printed logo that's also visible, or it actually could be a illuminated branding logo that only wakes up once the HMI is actually being activated. Similar to the previous example, this also has ambient illumination features to indicate the system status, capacitive slider to adjust the temperature, as well as capacitive buttons with illumination to control the basic features of the fridge and the freezer, just within a very different looking package. In terms of IMSE structure, this example has the same commonly used two-film IMSE structure than the previous one. Cosmetic film on top, functional film on the bottom, and injection molded substrate on the center. Again, creating a beautiful three-dimensional single-piece structure with one single electromechanical interface. Operating modes for this part, similar to the previous one, interface in the sleep mode on the first picture, and this is where none of the capacitive buttons are functional. All of the illumination is switched off, and also do note that almost all of the illuminated capacitive features are actually hidden in this case. The picture on the left, HMI, it is activated by the proximity sensor and activated in terms of the controls for the fridge by touching, in this case, the fridge icon that is also illuminated. The HMI also indicates that the fridge temperature has been set to level 3 out of 4 options by illuminating the respective numbers in green above the capacitive slider. And on the last image on the right, the HMI indicates that freezer temperature has risen by illuminating both the drop and freezer indicators, as well as by illuminating the red ambient illumination on the top side curve of the HMI. So that was our take on some of the intuitive, beautiful designs that can be done in case of refrigerator and freezer with the IMSE technology. But also to give you a little further ideas of what IMSE can be used for, I'd really like to invite Mr. Kabir Maiga, a co-founder from PassiveBolt, to introduce a little bit of what PassiveBolt and the Shepherd lock is all about, and to talk about the adoption of IMSE in this particular product. TactoTek is very proud to have Shepherd lock as the first smart home product coming to the market that integrates a smart surface built with the IMSE technology. So with that, Kabir, stage is yours. Welcome.
All right. Thank you very much, Vesa, for having me. And hello, everybody. Happy to be here and talk a little bit about Shepherd and our journey into smart home and how IMSE had a role to play in that. So today I just want to talk about 4 key points. We're going to go over just roughly 4 slides where I'm going to talk a little bit about us being PassiveBolt, the company, and talk a little bit about Shepherd, our product. And then next, I'll show you how we've used IMSE in our design. And then finally, I'll tell you a little bit about why we chose to utilize IMSE over existing technologies. So first, a little bit about PassiveBolt. We are a spin-off company out of Continental Automotive. We spun off back in 2018. Continental is a large, automotive tier 1. So I come from automotive. Formerly, I was, the technical lead for keyless entry technologies going into vehicles within Continental, and really leveraging that, the keyless entry technology that's fairly robust in vehicles. I decided with, my team to spin off from Continental, create a spin-off project, which is solely dedicated to the smart home market. But again, leveraging all of these robust technologies that we had coming out of automotive, setting out to essentially provide the same user experience that you would typically get in and out of a vehicle. So based out of Ann Arbor, Michigan, proud Michiganders, we have a flagship brand that we created recently, which is Shepherd. And under that brand, we're taking our first product to market. But really, at the core, we're more a B2B focused company, where we're looking to and have been working on partnerships with companies that are active in home automation, and that tends to be at a holistic level. Companies are, say, in home security, or they're let's say MDUs or builders, etc. So that's PassiveBolt. Now I'd like to tell you a little bit about let's say the product Shepherd. And Shepherd, again, our flagship brand. You can see the beautiful picture on the right of an elegant design in its simplicity, and I'll talk about how we achieved that using IMSE. But really what Shepherd does is it brings some of the convenience that we designed and developed in automotive, which is really the best way to provide intent to a device that you would like, let's say, something to happen, right? And that's the touch. Not fingerprint based, just the touch. We're utilizing wireless authentication, just like in vehicles. So when you come home, you're able to just touch your deadbolt. That's your existing deadbolt. Our product is a retrofit. So you would retrofit your lock and install it inside of the home. And then now you're able to just touch your deadbolt. You'll look for a virtual key. If it's authenticated, it unlocks and you go in. It's really as simple as that. Getting in and out of your house has never been easier. And then once you're in the house, right, you're also able to touch to lock or unlock. But of course, for egress, you do not need a virtual key. So you could see how we've basically taken our automotive roots and we've applied them in smart home by essentially bringing a simple way to get in and out of the house. Of course, we've added a ton of security features in the process, such as first to market tamper alarms. If somebody's trying to pick your deadbolt, first to market, breakdown alarms, or if somebody breaks down your door, we're able to detect that because we have this, again, first to market piece, which is our door open sensor, and that is fully integrated into the lock, so you don't need an additional sensor on the door frame, right? If somebody opens your door, we're able to track it live from 0 to 360 degrees if you're able to open it that wide, typically about 180. But that sort of technology allows us to do things like brute force detection, etc. With all of these innovations, we were awarded the CES Innovation Award for 2020 in smart home category in Las Vegas this year. We've won additional awards that range from IoT World, where we were listed as one of the best consumer products, best IoT products coming to market in 2020, named in Forbes as top 7 for 2020, etc., etc. We've been very blessed at the level of response we got for all of these innovative features that we're bringing to market. Now, a little bit about how we utilize IMSE to achieve all of this in this next slide. So the way we've integrated IMSE in our design, as you can see, this is the face of the product. That's the piece that goes inside of the house to retrofit your existing lock. You can see an LED indicator that's essentially integrated in the surface of the plastic using IMSE technology, right? Then right below that, you would see the touch sensor. I mentioned earlier that our product allows you to touch to lock and unlock from inside of your home as well. And that, it's a depressed area. It's not as obviously clear in this picture, but that area has got a slightly different finish than the rest of the surface, which is an indicator for the touch area. So you're able to touch that printed sensor, again, using IMSE technology. And then finally, our logo sits at the bottom, where essentially, because of the way it's designed with IMSE, we're able to, for B2B purposes, as an example, swap out that logo easily without having to do any sort of retooling, right? The surface is, very smooth, really nice, glossy finish with additional options for matte, should we go that path, but really nice, clean finish on the surface. That black piece snaps into the plastic, which is right around it, giving us a cover that's fully magnetized and could basically just be pulled out of the door and removed to access the batteries, right? That makes it an elegant design, where if you wanted to change your AA batteries, our product is battery operated. If you were low on battery, you wanted to change it, it's as easy as just pulling this cover out and you have access to the batteries to replace them. And then you snap this cover right back onto the product, right? So really elegant, high quality, great looking, simple finish that lacks complexity, but really, if you think about it, within the IMSE layer does carry some level of complexity, but again, it's to the user, it is just simple, seamless, right? You've got LEDs that are RGB, all colors that we use for feedback. We collect the touch seamlessly with that touch surface, and we're able to customize, like I said, from logo to logo if we, for B2B purposes. But for now, you can see it carries the Shepherd Lock logo. Well, why did we choose IMSE? Just to kind of continue on this IMSE, topic. One of the reasons is, again, as a B2B focused company, we wanted the ability to customize that cover, right? So we've essentially divorced the aesthetics of the lock with the functional piece, which is the module that sits right behind this cover that you're looking at. So essentially, with the IMSE top film, we're able to customize a logo easily. So if we were, let's say, white labeling the solution to a regional home security company that does not need to retool the cover to change the shape, but they would like their logo because they've got 10,000 or so customers, right? We're able to support them with that by simply changing these layers. That gives us flexibility in our go-to-market strategy. The second thing is, as you can see that finger with the touch, is we're able to achieve a touch sensor on the surface of that cover, which, like I said, we've decoupled from the module itself, but we're still able to drive LEDs and we're still able to drive the touch sensor seamlessly when you snap the cover back on, right? We have a well-hidden, let's say, electrical connection between the module and the cover, which gives us an ability to integrate this touch, right? Alternatively, we would have had to, from the module with this design concept, be able to detect within 2 layers of plastic a touch, which obviously in numerous attempts has proven to be challenging and error-ridden. And the best way to really go about it is to have that touch sensor right on the surface, so we can improve accuracy, we can improve this, we can simplify the design, and we can improve the user experience overall. And then, one of the driving reasons as well is just, again, continuing on this line of thinking of simplicity is eliminating unnecessary tools, right? By being able to put our LEDs in the plastic directly, being able to embed our logo and a touch sensor, we're able to simplify the top layer of the product, right? So instead of having to figure out a way, again, to add complexities in our mold to deliver an LED to the surface, all we have to do is drive that IMSE piece, and we can indicate using an LED. Same thing with the touch, which I talked about, right? Instead of having a complex way to try and figure out, which would likely include some complexities in our tool, to be able to get that touch to the surface with IMSE, or we were able to simply just drive that sensor that's printed directly on the cover. So between the B2B go-to-market flexibilities, the simplified tooling, and again the superior performance and better user experience that comes with it, IMSE proved to be the best choice for us for this specific solution that we were designing. And so we were happy to collaborate with TactoTek on this and be able to take the first IMSE-based door lock to market within this year. With that, I'm happy to answer any additional questions.
Very cool. Thanks a lot, Kabir. Very, very informative, and I think it's a really, really good perspective for us to have as well in a real application for IMSE. So I think with that we can get to the Q&A for questions from the audience.
Yes, yeah. Thank you, Kabir, and thank you, Vesa, for your very interesting and informative presentations. And now, our dear audience, is the time for your questions. And while you're sending out your questions in the chat box, we actually have a question for you, or a poll that we would like to get some answers from you, to hear your opinions. So the poll is that what kind of features you would like to see in home appliance HMIs? Would that be creative illumination and 3D shape design, easy to clean surfaces, efficient connectivity features, capacitive touch features, or maybe all of the above? So Vesa and Kabir, what do you think? Do you have some kind of preferences here?
I think that's a really good question. I personally would like to see all of the above.
Yeah.
Yeah, I would say to me, illumination and capacitive features make for elegant HMIs, period. Mm-hmm. There's nothing more powerful than a touch. It's simple. Anybody could do it if they have motor skills. So to me, that is just elegant. LEDs that are embedded just give anything really a semblance of, let's say, sophistication, right? It's that clean, dim LED feedback that just makes you and the machine feel like you're in communion, right? So to me, the combination of a well-illuminated interface that's got capacitive-based features tend to be superior in my assessment.
Mm-hmm.
Yeah, absolutely. And I think the audience kind of agrees with you guys. So all of the above is now the most popular answer, and then the second is the creative illumination 3D shape design. So very, very much in agreement there. Now, okay, let's look at the questions. Here is how is the Shepherd lock powered?
Yeah, so Shepherd operates off of AA batteries. We have 4 AA batteries that are easily accessible by removing the cover, and no tools are needed. The cover is magnetized, so you just snap it right off the wall and out the door, and you're able to swap out batteries. Just 4 AA's, standard batteries. It lasts you between 12 to 18 months, depending on your usage case. If you're using it about 12 times a day, that's about 18 months battery life.
All right. And then approximately how many LEDs are required to illuminate the ambient illumination section of the fridge panel, and does it cause an internal thermal issue?
I can take that question. So it really depends on the size and the brightness of the illumination that you're looking to reach. So to really determine an accurate quantity of LEDs, of course, we'd like to discuss with the customer and try to figure out what are the expectations in terms of brightness and uniformity for the lights. But something that you see here in the examples, I think the first design example that we had, you would probably be looking somewhere between 3 to 5 LEDs on the smaller one. The bigger one, the example that curves on the top, probably is going to be somewhere, anywhere up from 6 LEDs. But again, really depending on the size and the requirements of the panel. In terms of causing thermal issues internally within the part, anything, if you keep the lights on for years and years, absolutely. I mean, we can't unfortunately escape the laws of physics, so you will be creating heat. But typically in these use cases where you use the ambient illumination to signify something, you're not burning the LEDs all the time, meaning like extended periods of times. So within the use cases and applications that we've done, we haven't really seen an issue with illumination like that. Of course, once you step into high power LEDs, you step into a completely different region in terms of thermal management, and there are ways to do that as well. But within these sophisticated, simple use cases that we've done for appliances, so far it hasn't really been an issue for us.
Right, thank you. And then we have a question regarding the materials, and also there's, I can see in the chat box, there's a, I think this is a suggestion for the features that people would like to see in the consumer electronic HMIs, so that they would be antibacterial as well. Mm-hmm. And it's a good connection to question regarding the materials. So how do we make sure that the materials endure, for example, cleaning solutions?
It's a really good question, specifically in a time like this where we are in a global pandemic, where cleaning becomes more and more important, whether that's an appliance or whether that's a shared space or whatever that is. So we are really lucky to work with the leading companies in the world in terms of materials, anywhere from the films that we use into the components that we use in, as well as the substrates. So in the examples that you see here and what's widely used with PC PMMA films as well. Sometimes those films are hard-coded, sometimes they're not, depending a little bit on the use case. Making sure that the surfaces and the materials that we use are fit for to use for the customer, number one, and number two, to be cleaned. Of course, we run a lot of internal testing and work with suppliers and partners we have for those materials. Anything we see in terms of what's being built here, for example, with PassiveBolt, to the examples that we have on fridges, everything is being done with validated materials. So if you go back all the way to the slide where we showed the building blocks, and you remember the big purple box in the bottom, which is the platforms, the main really task for the platforms for us is to make sure that everything we push from those platforms into the actual products for the consumers is verified and validated against certain chemicals, among other things, of course. So it's a good question, and I'm not sure if I'm really answering that, but yes, we do make sure that the materials will last through the partners and with some very rigorous internal testing.
Yeah, thank you, Vesa. And I would like to add that at TactoTek, the core of our expertise lies also in the materials reliability verification. So that in that way, we make sure that we use the materials that can endure different use cases. And I recommend that you go to our YouTube channel to check out the IMSE verification webinar that we had earlier this year. So you will find a lot of answers to these questions.
Absolutely, and just to add to that, Tua, is if there's somebody in the audience who is interested to explore some very specific certain materials in terms of surfaces or on the other hand, some very specific chemicals that you might be worried about in terms of damaging the surfaces, we're more than happy to look into to those materials and chemicals and have a dialogue and see how we can help there.
Absolutely, and you can everybody see the contacts in this screen now where you can reach us. Then we have a question if we do injection molding in-house. So I can take this one. So the business of TactoTek is technology licensing. So we do some small scale production, R&D production, but what we do is that we license our technology and know-how to our customers. And this and other more of these kind of business related questions, you can find answers from our website. And also if you would like to know more, please contact us at sales@tactotek.com to get more answers.
Mm-hmm. And just to add on that, the licensing applies a lot, of course, more into the automotive world as well. But for example, if you look at the Shepherd log, which Kabir just talked about, we actually do production in-house, including all the phases of the production. So printing, SMT, thermoforming, injection molding. So everything's done in-house. So we do have capabilities. If you're looking at something that gets into millions in terms of yearly volumes, then we'll probably have to have a discussion about how do we utilize the partnerships and the network that we have, but we also do have capabilities to run production in-house.
Yes, and there's actually a question about our location. So the TactoTek headquarters are based here in Oulu, Finland, but we do have people like, for example, Vesa in the States, and we do have also people in Germany and in the Asia. So you can reach us pretty much from anywhere. And then we are kind of running out of time here, but maybe we could spend a few minutes discussing the trends in the consumer electronics markets, since we have two experts here, you, Vesa, and Kabir. So when you're discussing with partners or consumers, customers, whoever, do you see some specific features or trends rising up in the discussions?
There's a renewed emphasis on user experience, now more so than ever. In just about any new product design, and really it's actually sort of apparent also in the evolution of titles people carry in companies. You'll see it, that customer success and user experience has become the new focus. And so any incremental technologies you can add that would make a product more user-friendly, that seems to be an area of heavy focus and investments by many companies.
I'd have to agree with Kabir on that. I think that's exactly what we see as well. Is really the rise of appreciation and focus as well on how simple and seamless the actual interface to use whatever the product is. So I feel like we're going from the technology burst of having thousands of buttons in a appliance or having all these features kind of back into something that's really intuitive, easy to use. Of course, with the mega trends, like mentioned before, having something that's easy to keep clean within this really unprecedented time in the world is important as well. But yeah, Kabir, I'll have to agree with you on that. So user experience is a big thing, and gladly so. I think companies are putting more focus and are willing to spend more as well. So
yeah, all right, thank you guys. And then maybe a final question is that, are you getting a lot of requests for antenna applications so the user does not have to touch the part as much? So I think that kind of speaks for the need for the connectivity features that you also mentioned.
Yeah, yes, we are. To answer simply, we are getting more requests on that, and it's really a two-way street in terms of the user experience being better, but it's also comes back to the technical aspect of having those antennas in the surface. of the part rather than having them buried inside the structural elements and behind a circuit board. So the performance of the antennas we found on the IMSE applications are often superior to conventional electronic setups. But also the big reason for that is the user experience. So yes, absolutely. I think it's a fairly significant growing trend within the applications that we do within TactoTek.
All right, thank you. Okay, I think that's what we have time for today. And there was a question about the if we have, for example, automotive webinar coming up. So yes, we have plans for many other webinars this fall. So please make sure that you are subscribed to a newsletter, so you will be the first to know about those. But thank you again for joining us today, and thank you, Kabir, and thank you, Vesa, for your great presentations and this Q&A. And we hope to see you all online again soon. Thank you, guys.
Thank
Bye.
you.